Hello and welcome. Enrichment. Today we have a very different question. I haven't done one of these for in these lectures. We have actually to sketch this particular equation and some kind of curve. I don't know what it is. It's implicit and it looks a total and utter mess. Okay, where do we start with something like this? This particular question, I wrote it last summer, and it can be done with elementary mathematics. When I say elementary, I mean sort of like A-level techniques, standard A-level techniques. But the best way of actually doing this is actually using a little bit of further maths. It appears in two places, and my solution in one place, it shows both methods, and on the other, it shows only the further maths bits. So we're going to look at it from a further maths point of view, but I will give at some point during the question, or perhaps in the description of the video, the place you can actually find it with ordinary techniques. Okay, when I look at this, what choices do I have? I need to sketch, so certainly I won't be going for X and Y intercepts, stationary points, things like that. I won't be thinking about multiplying these brackets either. I don't think it's a good idea looking at what I've got in there. So what is going on in there? I'm looking at the second bracket, and the second bracket has something very, very special inside. This thing here, if you're a further mathematician, should remind you of something. And what should remind you is, of course, the R shine of X. In logarithmic form, that's in fact even in the formula booklet, is the log of x plus the square root of x squared plus 1. So that's practically there, except for the log, and it's not difficult to create a log in there. It's this one here that's a little bit of a pain, because we've got this 4 in there. So let's take logs first of all, and let's hope that somewhere along the lines we're gonna see what needs doing in there. So let's start the question. So the first step, because my motivation is of course that the R shine of X is this quantity, which of course is practically that, is to take logs in this particular equation. So the log of X squared, log of X plus the square root of X squared plus 4 and Y plus Y squared plus 1. And let's put another bracket to show better what we're doing. So we're taking the log of the left hand side is of course equal to the log of 2, which is just a constant, and this will allow us on the next line to split the log. So the log of, I didn't close my square root, the log of X plus X squared plus 4 plus now the log of this quantity, which of course now this will be the R shine, so we can replace it at any stage we are ready, is equal to the log of 2. So of course this is the R shine of Y. This is the problem now, and we still don't know. We just thought maybe it's got something to do with this. Maybe that won't work. So we're looking at the moment at this particular expression. It would be nice if we could perhaps manipulate it to something that we can use actually this formula. So what I'm going to do next, rather than carrying on with the equation, because I'll be carrying all of this all the way down, is to just concentrate at this particular log. And then once I know what I can do with it, or if I've hit a brick wall, I can't do anything, then of course I'll try something else. But for the time being, I'm just going to concentrate on this. So the log of X plus the square root of X squared plus 4 is equal. What's the problem with this particular log in order to make it look like this? Well, quite clearly this 4. How could I possibly lose that 4 now from the argument? I could write X squared plus 1 plus 3, but I don't think that's a sensible thing. I cannot think of a way of getting rid of that plus 3 that I would have created in there. So maybe I need to do something in a multiplicative sense. So definitely it would be nice if I had a 1 in there. I can create a 1 simply by factorizing a 4 out of the argument of the radical. So I can actually say that's definitely the same as 4 times a quarter x squared plus 1, close bracket, still inside the square root. So that's all sound. Okay, rules of surds allow me to split this surd now to the square root of 4 times the square root of that. So that's obviously a good idea. Let's have a look at least to what it looks like, and then we'll make a decision afterwards. So that's the square root of 4, so that's a 2. And now we're going to have a quarter x squared plus 1 inside the square root. Okay, so far so good. We have the plus 1. And if we look at this, we need something squared. Not necessarily x squared, but a squared quantity in there. That's actually rather nice, isn't it? Because a quarter x squared, I guess I can write it as this. Is not a problem, nothing complicated. Half x all squared plus 1. So that looks like I'm trying to create, perhaps, if that was replaced by half x, the r shine of half x. But what about him? Is not half x there. So what can I do next? Okay, see this 2, I also got this 2, this shouldn't be there. I want to get rid of that 2. How can I get rid of it? I can factorize this 2 now, inside the argument of the log still. So I'm going to pull it out of the radical and out of the x. So that's the log of 2. I'm going to put another bracket, and now I'm going to have half x. That's my 2 times a half, and of course that 2 from the radical, so plus the square root of all of this. Just rewriting it. I'm going to move out of the way in a second so we can just check that we haven't made any mistakes, or at least obvious mistakes. Okay, so this is my x when I multiply the bracket, and then of course the 2 times in front of this, so it's exactly the same. That is now some kind of r shine. I've got this annoying 2 there, and I've got the log. How can I deal with that? Well, I think it's easy. We can split the log. That times all of that, rules of logs, is going to be the log of 2 plus the log of half x plus the square root of half x all squared plus 1, close radical, close argument of log. This, of course, is now very special. If I replace x everywhere in this formula with half x, like I have here, this, of course, should be the r shine of half x. So this workings now, I'm going to take, because that's, of course, this was this bit here, and I'm going to replace it with its equivalent. So that's the log of 2 there, plus log of half x plus square root of a half x all squared plus 1, close surd, close log, and of course the rest. And I think now that can't be coincidental. It's too perfect to be just an accident. I think this should now be the end of the road for this particular question. Let's clear and make some board. Well, the obvious thing, as I'm cleaning the board, you should be able to see the log 2 should cancel. Oops, I rubbed it off from both sides of this particular equation. And then I'm going to have 2 r shines to deal with. And hopefully, let's not forget we're trying to sketch. Will that be easy to sketch is the question. So let's clear this log 2 and this log 2 there. And this is, of course, the r shine of half x plus the r shine of y is equal to 0. Is that difficult to sketch, or should we be doing something else? Because, of course, the r shine of half x plus the r shine of y is equal to 0. Well, I don't think I can sketch this as I see it, but of course, I'm thinking, can I get rid of these r shines? Please do not do something like I'm going to cancel r shines. It doesn't quite work like this. It's kind of ludicrous to suggest this. Let's move the r shines into separate sides. So I'm going to take this to the right. So it's going to be equal to the r sine of half x. And let's note that the r sine is an odd function. So, oops, I made a mistake, and there should be a minus there. Let's make a little bit more room with the equal. And let's see that. That's by moving obviously the r sine of half x to the right. Now, as I was saying, the r sine is an odd function. So this minus, I could actually move it inside the argument. So I can actually say the r sine of y is definitely equal to the r sine of minus half x. And now I have two identical functions, okay, on both sides, and the argument of one is y and the argument of the other is minus a half x. So the final implication is that this argument must be exactly the same as this argument, and therefore the required curve, all this mess that you got up there, should simplify to y is equal to minus a half x. I'm not going to waste time to rub off my board to do a sketch of the straight line y is equal to minus a half x after all of this, but this is essentially just a little kind of try a distractor perhaps when it says sketch this. It's trying to get you to go the wrong way by trying to do sort of things, look for other things and stationary points, to move you away from the real way of actually dealing with this particular problem. As I said earlier on, this you can find in two different places. This is the further maths version, which is actually the better one in my opinion to deal with this particular problem, but you can actually solve this particular one just with ordinary A-level techniques. I hope you enjoyed it, I hope you followed it, and who's laughing now?